Alrighty, let's get started with our Module 5, Lesson 15 problem set. And in this lesson, what we're going to be doing is we are going to be finding common units or numbers to compare two fractions. So we're continuing to compare two fractions, and this time when it says common units, we're looking for either numerators or denominators that are the same, because they're easier to compare when they're the same. So let's get started. Now in the first one, we're supposed to draw an area model for each pair of fractions, and then we are supposed to use it to compare the two fractions by writing greater than, less than, or equal on the line. The first two have been partially done for you. What does partially mean? Partially doesn't mean the whole thing's done for you. It means part. Partially. Part. Okay? Partially done for you. Each rectangle represents one. So in the first one, we're looking at 1/2, and we're looking at comparing 2/3. But what are those greater than or equal signs doing there? What are we supposed to do there? Well, this is just showing that it's a little confusing. What this line should actually be a closed line there, and what it's trying to show you graphically is that 1/2 is actually less than 2/3. And with this, what they're showing you is if you were to color in 1/2, okay, so we got to color in 1/2. Let's say we had 1/2 that we started with, and if we look at 1/2 and then turn that into 6 by decomposing it, we end up with 3/6. So what we end up looking at is 3/6. And another way of looking at that is to do 1 times 3 and 2 times 3. So really our half over here is the same thing as 3/6. And also, well, how does that help us with 2/3? Well, if we look down here, we can make this thirds into sixths also. Well, how do we do that? Well, let's say we start off with 2/3 now. We start off with 2/3, and just for arguments, we could start off this way and look at it a little bit differently. Let's look at it this way, because this would be actually if we were to start off with there's a third, there's a third, and then here's the last third. Okay, so there's our thirds, and then with those we would compose and turn that into sixths, and I see 1, 2, 3, 4, 6. Okay, or decompose rather that into 4 6. So here we have the multiplication part of it, where it's 2 times 2 is 4, and 2 times 3 is 6. So basically we've made these both into sixths. We've made 2/4 into 4 6, and we've made 1/2 into 3 6. Well, of course, 4 6 is greater than 3 6. All right, so there you go. Well, let's go on. It said uh, the first two have been partially done for you, so the next partially done is going to be B. Well, it doesn't tell us which one's bigger or smaller, but it did start to draw at least our what we're starting with. We're going to start with 4/5 going this way. 1, 2, 3, 4, 5, 4/5. We're going to start here and go 1, 2, 3, 4/5. Okay, and then on the bottom one, we're going to be looking at 3/4, but we're doing it horizontally. 1, 2, okay, and 3/4. Okay, and then how we're going to figure this out is because we're going the opposite directions, we have to think, well, 5 and 4. Well, 5 and 4, the only thing they're going to have in common would be 20. So what we're going to do now is we're going to take those lines and we're going to cut this into these 4 pieces. So we're going to cut this into 4 pieces. Okay, 1, 2, 3, 4. There you go. And then we can look at, well, what is our results here? Because this is the same thing as saying 4 times 4 and 5 times 4, which is going to equal 16 20ths. And if we were to count all these up, we definitely have 16 20ths here. And then on our bottom one here, when we start with our 3/4, we're going to go cut them downward. We're going to cut down 5 pieces. 1, 2, getting a little messed up here. 2, 3, 4, 5. So actually we're going to have 1, 2, 3, 4, 5, 10, 15, 20. Okay, so we have 20s again. And the math, how does the math look? Well, the math looks like it's going to be 3 times 5 plus, and then over 4 times 5, and that's going to be 15 20ths. That's going to equal 15 20ths. So we have 1, 2, 3, 4, 5, 10, 15 20ths. Well, we started with 4/5. 4/5 is 16 20ths. And 3/4 is 15 20ths. So therefore, which one's bigger? 16. 16 20ths is bigger than 15 20ths. So this one is bigger. But I know some of you are saying, well, why do I have to do all that work? I know that these is 4/5, that 4 of those 4/5 is going to be bigger than 3/4. Well, you got to do the math to find it out. So let's continue along on the next ones. Okay, so for the next one for C, we're going to need to split it up into 5ths and 7ths. So we're going to do 5ths with our vertical lines and then 7ths in our horizontal lines. And then of course you're going to want to color in how many of those. So we're going to have 3 over here, 3/5, and then going this way, we're going to have 4/7. So I'm going to do 4/7 in here, 2, 3, 4/7. And it's really hard to tell which one is bigger until we do the math. Well, when we do the math, what we're actually doing when we split these up further is this one, we're cutting it now this way into 7ths. 1, 2, 3, 4, 5, 6, 7. We're into 7ths. And so we have 1, 2, 3, 4, 5, 6, 7. We should have 21 of these here. And then on these going down, we're going to split these into 5 pieces. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5 into 5ths that way. And here we should have, these are 5, so we should have 5, 10, 15, 20. Okay, in this section here, we should have 5, 10, 15, 20. Okay. Okay, so let's see, well, what does the math look like? Well, here's what the math would look like on this top one, on this 3/5 here. I'm going to do this one over here. I'm going to have 3 times 7. Well, why 7? Because we split this up, the 3/5 7 ways, times 5 times 7. So the top one is going to equal 21 35ths, because now we have 7 times 5. And you'll see the bottom one's also going to be 35ths, but we're going to start off with 4. And we're going to go 4 times, not by 7, but because we split that one 5 ways. So we split that 5 ways. And then we're going to have 7 times 5. And so what we have here is 5 times 4 is 20, 35ths. So look at how close that is. These two are only off by 1/35, but very, very slightly, the 3/5 is bigger. Very, very slightly, the 3/5 is bigger. Okay, go ahead and hit the pause button and hit play when you're ready to check all the rest of these. Now, in the interest of saving time, I'm not going to do the area models for all of these. We've done them for 3 of the problems, and I think that's probably sufficient. So if we just work the actual mathematics, we find out that 3/7 is actually going to be larger than 2/6. And we'll do the same for the next two. We'll just do the mathematics. So go ahead and hit pause again. Alrighty, so there are your answers. Bada bing, bada bang, bada. There they are. And it's up to your teacher whether your teacher wants you to do area models on all of these, but some of them get quite involved. For instance, on E here, if we were to do them, we would end up making 72 little squares, and that's an awful lot. So, I mean, I can sort of understand, well, these aren't that big. We could do these because all we're going to do here is we're going to start off with 2/3, which is not that bad. We're just starting off with 2/3. And then the other one, we're only starting off with 3/4, so that's not so bad. So some of them are not really that bad, but some of them are. This one is not too bad because we would just make this into 3/4. Okay, and then we would, for the top one here, it says it's times 4, so we're going to cut that into 4 pieces. So it would be, which isn't too bad because then we have 1, 2, 3, 4. We have 8 here, 8/12, and then on the bottom one, we're going to cut it the other way. Or actually, I cut this one the wrong way, but either way, we're going to end up with 9/12. So there you go. Let's just move along to the next page. I'm not going to, well, you should finish it if you start it. All right, well, we did them both the same way this time. We didn't do vertical and horizontal and blah, blah, blah. But if we cut this into 3 pieces, it's still going to be the same thing. We're going to have 9/12. 9/12. Okay, there we go. Now we can move on to the next. Okay, let's go to the next page. Welcome to the flippity flippity doodah side. Okay. And on this page, we're going to rename the fractions as needed using multiplication in order to compare each pair of fractions. Okay. And by writing greater than, less than, or equal. Okay. And we're just going to use the multiplication this time. And no drawings. Yay, we don't have to do drawings. Okay, so basically what we're doing is we're going to be doing the 3/5. And we are going to times that by 6. Why by 6? Well, it's not magic. We have to do the 5 times 6, okay? And that's going to equal, oops, 3 times what? 3 times 5, okay? 3 times 5. So we have 15/30. So, oh, that doesn't look right. 3 times 6 it's supposed to be. All right, let's get that fixed. This is supposed to be 3 times 6. Come on, get it together. This is not supposed to be 15. It's supposed to be 3 times 6. All right. So let's do that. Let's get 3 times 6. Okay. 3 times 6. Because whatever you do to the top, you do to the bottom. 3 times 6. 6 times 3 is 18. 18/30. So this one is 18/30. And then the bottom, we're going to do times 5. 5 times 5 and 6 times 5. 5 times 5 is 25. 6 times 5 is 30. And so this one's 25, this one's 30, so we have, this one is bigger. Okay. 25 is bigger than 18. And you do that for all these. We have to do the multiplication. Like for 2, 6, so it's going to be 2 times 8 and 6 times 8. Gotta know those times tables. So it's 48. 6 times 8 is 48. And 8 and 8 is 16. So this one is 16. And then the other one here is going to be 3/8. So 3/8 is going to be times 6. Times 6 times 6. That equals 6 times 3 is 18/48. So those are very close together. But the winner is, dun, 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 dun. Yeah, you got it that way. Okay. And pause the video and do the next two. Hey, wait a minute. You said do C and D. Well, I'm going to show you a little bit differently on this D, only because we have more than one hole on both of those. I'm going to change that 4/3. I'm going to change that with a bond here to let's see, I'm going to change that into 1 whole, so we have 1, which is 3/3, and 1/3, okay, 1/3. And over here for 6/5, I'm going to change that into 5/5 and 1/5. Okay, so the way I look at this one here is that 1/5 is greater than 1/3. So I just don't want you to forget about there's always more than one way to do a problem. We could do this by turning this into 15ths, but I just want you to recognize that you can always do other ways and know that 1/3, a third is bigger than a fifth. So there's more than one way to do these problems. They wanted to do it by multiplication, but I just wanted to show you that there are other ways. So let's move down to the next section. And this section says to use any method to compare fractions. Any method. Oh, good, any method. All right, well, I have 3/4 and 7/8. Okay, well, that's easy. I want to change those fourths into eighths. I'm going to go 3/4 times 2 times 2. 6, that equals 6/8. So 7/8 is bigger. There we go. Got that one done. And then for this one, let's see, what can I do here? Let's change them all to 40ths. So I'll go 6h times 5. So that's going to equal 30 40ths. Okay, and then I'll look at 3/5. 3/5, so 3 times 8 and 5 times 8. 8 times 3 is 24 40ths. So therefore, let's see, which one's bigger? 30 is bigger, so 6/8 is bigger. There you go. And pause the video and do the next two any way you like. Alrighty, how'd you do? Well, I did one using the method of doing multiplication to get a common denominator, which is 24ths in this case, and it ends up being 6/4 is greater than 8/6. And this one I did the old number bond. And then I came up with 3/5, so they both are 3 pieces. And as I know, fifths are going to be bigger than 6, so that's how that one works. All right, let's go on. We have one more to do. Explain 2 ways you have learned to compare fractions. Well, this one, folks, you're on your own. Explain 2 ways that you've learned to compare fractions. Because this is wrapping up all the ways we've learned. You can talk about area model. You can talk about common units, either common denominators or even common numerators. Sometimes if the numerators are the same amount, it's easy. If the denominators are the same amount, it's easy. And go ahead and give it your best shot, and I'll catch you next time. Same time, same place. Hasta la vista, baby. Psst, it's over. You have to do the last one by yourself.